titration, the practical we did last time, I told you that acid, we can define acid as a substance that dissolves in water to produce hydrogen ion as its own positive ion. Acid is defined as a substance that dissolves in water to produce hydrogen ion as its only positive ion. An acid is a substance that dissolves in water to produce hydrogen ion as its only positive ion. Example: HCl, hydrochloric acid, H2SO4, tetraoxosulfuric acid. We call them acids because when you dissolve them in water, they will ionize or dissociate to produce hydrogen ion as its only positive ion. For example, let us dissociate HCl. HCl dissolves in water to give hydrogen ion plus chlorine ion. H2SO4, tetraoxosulfuric acid, will also dissolve in water to give us 2 atoms of hydrogen plus sulfate ion as its own positive ion. So we have hydrogen ion. When hydrochloric acid dissolves, it will give us hydrogen ion as its own positive ion. H2SO4 will also dissolve in water to produce 2 moles of hydrogen as its own positive ion. So that's why we call them acid. We can classify acid based on its nature. Example, we can classify acid as organic and inorganic acid. Acid can be classified into 2, namely, number 1, we have organic acids, inorganic acid. Organic acids are acids gotten from animals and plants. Examples of organic acid, let's look at some examples. Organic acid, sources. Number 1, ethanoic acid. Ethanoic acid. This acid is gotten from vinegar. We have lactic acid. Lactic acid gotten from milk. Amino acid. This one is gotten from proteins. We have fatty acids. This acid is gotten from fats and oil. There's another type we call ascorbic acid. Ascorbic acid gotten from oranges. We have citric acid that is gotten from limes and lemon. Now let's take a look at inorganic acid. This type of acid is gotten from the chemical reactions of elements. Example, we have H2SO4. Okay. Inorganic acid. Let's take a look at inorganic acids. Acids gotten from the chemical combination of elements. Examples of inorganic acid like H2SO4, hydrochloric acid. Hydrochloric acid, that is HCl. You have tetraoxosulfuric acid. H2SO4. You have triazonitrate acid. HNO3. We call them inorganic acid because they are gotten from the chemical combination of elements, while organic acids are actually gotten from animals and plants. Now, you can also classify acids based on their ionization. What do I mean by ionization? When you dissolve acid in water, that is ionization. So when you dissolve acid in water, they will ionize or dissociate. So you can also classify acid both on the degree of ionization. For example, that will lead us to what we call strong and weak acid. Now let's classify acid. Based on ionization. Number one, you can classify acid based on ionization by, we have two types of acid. When you classify acid based on ionization, we have two types. There's one we call the strong acids. The strong acids. What are strong acids? These are acids that ionize completely in solution. These are acids that ionize completely in solution. Example of strong acid: H2SO4, this is a strong acid. HCl, hydrochloric acid, is also a strong acid. Triazonitrate acid is also a strong acid. We call them strong acid because when you dissolve them in water, they will ionize completely. They will produce large amounts or quantity of hydrogen. That's why we call them strong acid. Now let's look at weak acid. We have weak and strong acid. The weak acid. These are acids that ionize partially or incompletely in solution. If you dissolve them in water, they will produce a very small quantity or amount of hydrogen. They ionize partially. Ionize partially or completely. Partially or incompletely. Incompletely in solution. So weak acids are acids that ionize partially or incompletely in solution. Examples of weak acid, e.g. ethanoic acid is a weak acid. This ethanoic acid. Triazocarbonic acid is also a weak acid. Then you have triazosulfate 4. This is also a weak acid. Which we have tetraozophosphate 5. These are weak acids. But when you dissolve them in water, they will ionize partially or incompletely in solution. Now, let us look at the physical properties of acid or the basicity of an acid. What is basicity of an acid? What is the meaning of basicity? What do you understand by basicity? Basicity of an acid is simply the number of replaceable hydrogen ions in one molecule of an acid. Basicity is defined as the number of replaceable hydrogen ion in one molecule of an acid. In one molecule of an acid. Example. Basicity. Let's look at these acids and their basicities. Basicity. I have the acid. HCl, for example, hydrochloric acid. Hydrochloric acid you ionize to produce 1 mole of hydrogen. So you can see we have only 1 molecule of hydrogen. So the basicity of this acid is monobasic, or 1 is monobasic. This is monobasic acid. Monobasic. You know, mono means 1, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 hepta, 8 octa, 9 is nona, 10 is deca. So hydrogen ion here is 1. So the acid is monobasic. That's the basicity. Now let's take a look at H2SO4, tetraoxosulfuric acid. What the basicity of this acid? This will ionize to give us 2 moles of hydrogen. You can see we have 2 atoms of hydrogen here. So the basicity is dibasic. This is dibasic. Dibasic. Now let's look at ethanoic acid, CH3COOH. This acid will ionize to give us you can see we have only 1 atom of hydrogen. So this acid is monobasic. The basicity of this acid is monobasic. Now let's look at the physical properties of acid. So I'll ask you in the exam, maybe in the exam or test, I will list some acids. I will ask you to give me the basicity of this acid. Though you ionize them, you write the hydrogen constant. Now when you break them, you now know the number of moles of hydrogen given out. From there you get your basicity. For example, I can give you hydrogen sulfate or tetraoxosulfuric or any acid I feel like giving you. So you tell me the basicity. So let's look at the physical properties of acid. What are the physical properties of acid? Well, if you're asked in the exam to give the physical properties of acid, now let's look at the physical properties of acid. Now you know the meaning of basicity. That's the number of basic hydrogen ion in 1 molecule of an acid. When you dissociate an acid, HCl, it dissociates to give us hydrogen, 1 mole of hydrogen and chlorine. You can see we have only 1 molecule of hydrogen, so it's monobasic. H2SO4 we ionize or dissociate to give 2 moles of hydrogen and sulfate ion. So we have 2 atoms of hydrogen. This is dibasic acid. Ethanoic acid will ionize to give ethanoate ion and hydrogen. So we have only 1 mole of hydrogen. So this is monobasic acid. Now let's do the physical properties of acid. The physical properties of acid. The physical properties. Physical properties of acid. Number 1, they have sour taste. Number 2, strong acids are corrosive. Strong acids are corrosive. Strong acid, if you pour them on your skin, it's very, very dangerous, very corrosive. So strong acids are corrosive. Number 3, they show different color change. Different color change in different pH media. Different pH media. So when you use indicator, for example, blue litmus paper, when you dip it into an acid, it will change to red. Blue litmus changes to red in an acid. Phenolphthalein changes to colorless in an acid. Methyl orange, when you add 2 drops or a drop of methyl orange into an acid, the color will change. Methyl orange changes to pink. So these are indicators. When you drop them inside an acid, you see the color change. Now let's look at the chemical properties of acid. The chemical properties of acid. Let's start with the first one. Chemical properties of acid. The chemical properties. Number 1, reaction with zinc. Reaction with metals. Metals that are both hydrogen in electrochemical series. When you add zinc to an acid, or calcium or magnesium, those metals are both hydrogen in electrochemical series. They will liberate hydrogen from acid. So when you add a metal to an acid, there will be chemical reaction. there will be evolution of hydrogen, but it's only metals that are both hydrogen in electrochemical series that will liberate hydrogen from acid. So reaction with metals, hydrogen is liberated. When metals are above hydrogen in the activity series. If you don't want to call it activity series, you can call it electrochemical series. When metals are above hydrogen in the activity series is added to an acid. For example, when you add zinc to an acid, zinc solid plus hydrochloric acid aqueous, this will react to give us zinc chloride plus hydrogen gas. This equation is not balanced. Let's balance it now. We have two atoms of chlorine here, one atom of chlorine. Zinc is one. So let's balance. We need to add 2 here. When you add 2 to this equation, hydrogen is 2, chlorine is 2, zinc is 1, So this equation is balanced. This is hydrogen gas aqueous. So when you add zinc to an acid, it will liberate hydrogen. Not only the magnesium will also liberate hydrogen from acid. Those metals that are above hydrogen in electrochemical series will liberate hydrogen from acid. Now, second one, let us look at the reaction with triazo carbonate. Reaction with triazo carbonate 4. When you add acid to a triazo carbonate 4 salt, there will be a chemical reaction. There will be evolution of carbon 4 oxide gas. For example, this calcium triazo carbonate 4 added to an acid, HCl. When you add this to an acid, there will be a chemical reaction. It will liberate carbon 4 oxide gas. This will give us calcium chloride plus H2O plus CO2. Is the equation balanced? Now let's balance the equation. Chlorine, we have 2 atoms of chlorine here, 1 atom of chlorine. Calcium is 1, carbon is 1, oxygen is 3 atoms of oxygen, 1 atom of oxygen, 2 atoms. So oxygen is balanced. Let's balance chlorine by adding 2. This 2 now means that hydrogen is 2. 2 atoms of hydrogen, chlorine is 2. So the equation is balanced. So when you add acid to a carbon and salt, there will be effervescence. The gas liberated is carbon 4 oxide gas. You can also take this reaction, you can add magnesium or magnesium carbonate. It will also give us the same effervescence. When you add magnesium carbonate on acid, this will also react to give us magnesium chloride plus H2O plus CO2. Now let's look at the third reaction. The first one is the reaction with metals. This is the reaction with triazo carbonate 4. The third one is the reaction with bases. When you add acid to a base, it will react to form salt and water. That type of reaction is called neutralization reaction. That's what we call neutralization reaction. So if I ask in the exam, define neutralization reaction, it is the reaction between an acid and a base to form salt and water. So addition of acid to a base, it will react to give us salt and water. It reacts with bases. To give salt and water. Salt and water only. And this reaction is called neutralization reaction. Example, let us react sodium hydroxide, a base. Sodium hydroxide with an acid. This sodium hydroxide reacting with an acid, HCl. This will react to form sodium chloride plus water. So this neutralization reaction happens. So when you mix sodium hydroxide with an acid, it will react to form salt and water. So acid react with bases to give salt and water. The reaction is called neutralization reaction. So I'll ask you the exam, define neutralization reaction. It is the reaction between an acid and a base to form salt and water. Now let's look at the uses of acid. At the last part of this topic on acid. Number 1, H2SO4, tetraoxosulfuric acid. H2SO4. This is tetrahydrosulfuric acid. Is used as an electrolyte. In lead acid accumulator. Lead acid accumulator is a car battery. The acid inside inside the car battery is H2SO4. It is used as an electrolyte in lead acid accumulator. Number 2, H2SO4 can also be used as a drying agent. It's used as a drying agent. And also in the manufacture of fertilizers. Number 3, triazole acid, for example. Triazole acid is used in the manufacture of fertilizers. That's the main use of this acid. Used in the manufacture of fertilizers. Citric acid, for example, citric acid is used in the manufacture of fruit juice. It's used in the manufacture of fruit juice. Number 5, fatty acids is used in the manufacture of margarine. Ethanoic acid, number 6, ethanoic acid. Ethanoic acid is used as a preservative. Okay, let's talk about this now. Number 6, this is the last part of this topic on acid. Now let me give assignment on acid. In our next class is enter basis. Okay.
Action.
Make a note on acid. Use your textbook, your Bible. Write on the uses of acid. Write out the acids you know and their uses. Make a note on acid. In our next class, we'll start with basis. And I'll give you the classwork in the next class.